All right, let's do some more limit problems. Remember, anytime I ask you to evaluate a limit, the very first thing you should do is plug it in, direct substitute. Plug in your number and see if you get an answer. If you get a number, then you're done. Your limit is that number. Now remember, if you get 0 over 0 though, there's a hole. You've got to get rid of that hole and then figure out where your path is at. If you get a number over 0, then that means you have a vertical asymptote. And then there's only 3 options. As we approach that vertical asymptote, is your graph going to go up, up, down, down, or 1 up and 1 down? If they both go up, you're going to say it approaches positive infinity. If they both go down, you're going to say it approaches negative infinity. And if one side goes up and the other side goes down, we're going to say that the limit doesn't exist. But we have to be able to tell the difference, right? All right, let's do 2 more. We're going to do example number 7 and example number 8 in this video. If you look at example number 7, we're evaluating the limit as x approaches 4 of the square root of x minus 2 over x minus 4. The very first thing we're always going to do is direct substitution. I'm going to plug in my 4 to the numerator and denominator. The square root of 4 is 2, 2 minus 2 is 0, and then 4 minus 4 is 0. So I end up getting 0 over 0. Do you remember what that means? A hole. But just because there's a hole doesn't mean that my limit doesn't exist. We have to get rid of the hole and then resubstitute to figure out where we're at on our path. The problem is this one looks a little bit funky. On all the other examples, we were able to factor and get rid of the hole, right? But this one isn't really factorable. So remember, there's a second method of simplifying by rationalizing. We can rationalize, this time, the numerator. We can get rid of the radical on the numerator and see if that'll help us figure out our limit. So what we're going to do is we're going to take our original problem, the limit as x approaches 4 of the square root of x minus 2 over x minus 4. We're going to multiply both the top and the bottom by the conjugate of the top. Do you remember what that is? That's the same terms, but the opposite sign in between. So I'm going to multiply the top and the bottom by the square root of x plus 2 in the numerator and the denominator. The opposite, the conjugate of the top. What I have to do now is then FOIL. I'm going to take my numerator and I'm going to FOIL. I'm going to do the square root of x times the square root of x. Well, the square root of x times the square root of x is really the square root of x squared. And you know that the square and the square root cancel, right? So you're just left with an x. Then you're going to do the square root of x times positive 2, so 2 rad x. You're going to do negative 2 times the square root of x, so negative 2 square root of x. And then you're going to do negative 2 times positive 2, or negative 4. So you should have something that looks like this. You might notice that those middle terms are the same exact thing, just one positive and one negative. Those are like terms that are opposites. When I have like terms that are opposites, a positive 2 rad x and a negative 2 rad x cancel each other out. That's why we multiplied it by the conjugate, so that it would do that. And so really, in my numerator, I just have left the x minus 4. In my denominator, I'm not going to FOIL. It's kind of a trick. If you don't FOIL, look what happens. I'm just going to leave it with these two factors being multiplied by each other, the x minus 4 and the square root of x plus 2. Look what happens. You may notice that I have an x minus 4 in the numerator now and an x minus 4 in the denominator. Isn't that cool? It always happens that way. Or always is a strong word, but every time I've seen it, it always happens that way. I have an x minus 4 in the numerator and I also have an x minus 4 in the denominator. If you FOIL the denominator, you wouldn't be able to see that as clearly. So FOIL the top, but leave the denominator the same. Always happens, I've seen it. That the factor of the top and the factor of the bottom cancel each other out. And so when I schmear, what did I just do? I just got rid of that hole, didn't I? I got rid of the hole, and so now I can figure out where our path is at on our new function. Now if I crossed off the x minus 4 on top and bottom, what's left in the top? Be careful. There's a 1, right? And so there's a 1 there. And so now I can do my direct substitution. I have 1 over the square root of x plus 2. I can substitute in a 4, and I end up getting 1/4